So what is Gadgeteer? Gadgeteer is an open source specification maintained by Microsoft that builds upon the .NET microframework and standardizes the connections between main boards and modules using cables and sockets. To best understand the need for Gadgeteer, I think it helps to step back and take a look at the way microcontroller platforms are traditionally developed. So this is a traditional one board microcontroller development platform. You see it's got a piezo buzzer, it's got speakers out and microphone in and power, it's SD card, LED, Ethernet, switches, whole bunch of LEDs. Um, you can build a ton of things with this, and you can really test out the microcontroller chip and see what it's capable of. But despite all this power, it really has just as many limitations. So if we want to rapidly prototype something, then we're basically constrained to the components that are on the board. And although there is some pin out capabilities, if we want to go beyond what's on the board, we really have to basically create our own electronics and figure out how to make all these things work together. And what if once we got this working, we decided we wanted to make this a one-off production unit, or maybe we wanted to do a low quantity run? These boards can often cost hundreds of dollars, and it's not a very practical way to do this. Ideally, you'd only pay for those components on the board that you used for your design. And so this is where the need for modularity comes in. So if we move beyond this type of board and introduce ourselves to the Arduino type form factor that's been popular for several years now. This basically uses a main board, and then it has the different components. Instead of being part of the main board, they all come on their own shields. So you could buy a music module that is already knows how to play music. You could have one that has temperature sensors on it. You could have one that runs an SD card, and you just stack all these things together. And if you have custom circuitry, you could do that on here also. But this also has some limitations. Although we get the modularity we're looking for that we didn't have in the one board design, this also introduces some new problems though. Because the shields stack on top of each other and they use a shared pin design, it's up to the designer to know which pins are being utilized by which shield, and oftentimes there will be conflicts because one shield may use pin 1 and then the other shield also needs to use pin 1. And what do? Sometimes that means you have to go modify the shield by soldering on a wire or some sort of hack to make it work. There's also the problem with driver software. So with this type of design, the IDE that you create your applications with doesn't help you tie the software that you need for each shield into a nice uniform application. Usually you have to go and search the internet or download the drivers from a manufacturer's website, or just write the drivers yourselves, because often they don't exist, or they don't exist in a form that you need. And one other limitation to point out is if we wanted to take this and put it into a case and use it as a one-off run, we're limited to the placement of the components. So here we may have microphone jacks in and out, power, Ethernet. They're required to be right here. I can't say I want to build an enclosure that has the power back here and the microphone jack on the side. And also, depending on how many shields I've got stacked on here, this can get really tall, which makes for an awkward case design. So although this solves the modularity problem and allows for a rapid development of application, it still has some limitations. So we enter the Gadgeteer, and first thing you're going to notice is that the modules on this guy are connected to the main board using cables. So this uses a 10-pin socket and a 10-wire ribbon cable. And notice that the shield size, the module size in this design is much smaller. So my PCB is only required to be as large as the module itself needs to be. So this makes the modules much cheaper to design than a shield, which would have to be the full size of my main board. Currently, there are over 100 different types of modules available for Gadgeteer, and the number grows almost weekly. There are simple modules for buttons and LEDs, complex modules for playing FM radio and reading OBD2 data from your car, and many others in between. Also, most modules come packaged with working software drivers, so you don't have to worry about surfing the web, looking for the latest drivers, or wasting time writing your own. In most cases, the Gadgeteer module is as easy as plug and play. We'll go into detail about the available modules and module design in our Modules Everywhere lecture coming up soon. So let me give you a brief history and let you kind of understand where Gadgeteer got its roots. Back in 2004, Microsoft came out with a technology called Smart Personal Object Technology, or SPOT for short. It was first implemented in a watch called the Spot Watch and in some other small appliances such as coffee makers. And at the root of the technology was a service called MSN Direct Wireless Data, and that used an FM radio band to deliver data from servers to your watch or your appliances. The Spot Watch had a rather short life, and in 2008 it was discontinued, but the technology continued to be used. Garmin picked up the technology and used it to deliver map updates to their GPS units. In November of 2009, Microsoft decided that the Spot technology was becoming a little antiquated and was no longer going to be a source of revenue. And so rather than dispose of the technology, they did a great thing, and they released it under Apache 2.0 open source license on Codeplex as the .NET Micro Framework. Microsoft and the community that grew around the .NET Micro Framework continued to improve the technology, and over the years it evolved from a hardware design that was originally based on the Arduino form factor to the Gadgeteer design on July 29th, 2011, when the first Gadgeteer was born, the GHI Electronics Fez Spider. Just a few months later, in November of 2011, the first open source hardware design for Gadgeteer was born as the Fez Hydra, also by GHI Electronics. On January 1st, 2012, Microsoft decided to turn off the MSN Direct Transmission service and put an end to the era of the Spot Watch. So now you know what Gadgeteer is and a little bit about its history. Let's go learn a little more about the details.